Hi, welcome to the Mentored Engineer. In this video, we are going to look at how to use our hydraulic hose calculator. Now, this is a wonderful thing. I use this all the time. I wish I had this tool many years ago. All right, so what you're going to do is you're going to go to the mentoredengineer.com and you're going to type in the search box hose calculator. So let's go ahead and do that. And there it is, first thing, hydraulic hose size calculator. And this is just a must-have here. All right, so first thing you're going to need to do is start filling out the 5 bits of information it requires of you in the top. So the first one is what type of oil are you going to use, and these are the 4 most prevalent types of hydraulic oil. We're going to stick with ISO 32. We're going to pick an operating temperature range. Typically this is somewhere between 104 degrees and 120 degrees. So we're going to go with, let's just say 110. And we're going to look at our flow rate. Now let's just say we have something small, let's say 6 gallons per minute. And I have a hose that's, let's say 50 feet long. All right, and then our last thing is our equivalent roughness, which is usually for a hydraulic hose 0.00015 feet. All right, and I'm going to go ahead and hit calculate. And at this point, it's going to give us some information here of our density, which is 7.16, our absolute viscosity in centistrokes, and that's 27.8, and our dynamic viscosity in centipoise, which is 23.9. And I'll be honest, I can't tell you what those mean or whatever, but they're using the calculations. All right, so here is the important part. We have different hose sizes ranging from 0.13 to 2 inches, and calculates our hose area, the inside diameter of the hose, our velocity, Reynolds number, relative roughness, friction coefficient, and that changes with the diameter, our pressure drop to push this across, and then the equivalent horsepower that it requires to do that. Okay, so right off the bat, we don't want certain sizes. Like this is way too small for an 1/8 inch hose to push 6 gallons a minute because it requires 51,000 psi and 181 horsepower just to do it. You probably tear up your hose pretty quick too. All right, so we put in a color-based system here where our suction lines, generally we want flow below 5 feet per second. That's a nice smooth oil coming out, so that's green. A return line is less than 10 feet per second. We're not building up too much pressure, but we're still keeping our velocity fairly quick. And we also want that to be less than a 2,000 Reynolds number. On our pressure lines, we can go up to 20 feet per second and less than a 3,000 Reynolds number. And then anything above 20 feet per second or a 3,000 Reynolds number, we will ignore. Okay, so we can see here that all the way up until 0.31 is a no-go on our calculation. A 3/8 would be a good pressure line. 1/2 inch and 5/8 would be good return lines, and then anything 3/4 inch and up would be a great suction line. All right, and we can see how these numbers go across that. Okay, in the 3/8 hose, it takes 2.5 horsepower to move that fluid. Well, that may be a little bit more than I want to put into it. Going up to a 1/8 inch or a 1/2 inch hose cuts that into fourths. So that's our thirds. So that's pretty good. And if we go up to 5/8, it cuts it down even further. So we dramatically save on horsepower here. So very simple tool, very easy to use. Yeah, good calculator. So thanks for using this tool, and hope it's valuable to you. Have a great day.